30-3s. Here we are, second lesson for trigonometry. Trigonometry, angles, sides, in triangles or shapes, but mostly in triangles. Very quickly, from yesterday, we looked at Pythagoras. Right angle triangle. If you have two sides, you can find the third side using Pythagoras. If you have two sides and one of them is the hypotenuse and you have another side, you can find the non-hypotenuse using a form of Pythagoras. However, Pythagoras does not utilize angles. What we're going to do today to work with angles is use the trig ratios. Now, nice, it's a review, so hopefully it'll come back to you fairly quickly before we go into non-right triangles next lesson. So we're going to look at trig ratios, the old SOH TOA, that works for right triangles as well. But whereas Pythagoras is just sides, now we start to incorporate angles. If we know that's 48 degrees and we know that this is 50, well, what's that side? Well, we can do this using one of the trig ratios. We have the sin or sine button, we have cosine, and we have tangent. And those are the three trig ratios we will focus on today. Before we get started, last thing, every time you go to do trigonometry and we're working with angles, we need to make sure our calculator is in degree mode. Now, if you have a graphing calculator, you can see that it says degree up at the top. If you're not sure, you can always hit the mode button, the button that's highlighted red. And the fourth line down, we see that it says radians and degrees. So the radians and degrees here, fourth line down, we want to make sure that it is degree that's highlighted. So if it's not, you want to hit, like let's say that the radian is highlighted, you want to highlight degree using your movement keys here, your cursor keys. You want to go on degree, hit enter, now it's degree, now we clear it and we're in degree mode. Make sure every time that you're looking at that. So with that in mind, here we go. All right, first thing with the trig ratios is the idea of a reference angle. We're looking at page 6. I'm kind of going to add a little bit. You might want to jot some of this down. Every question we do works with one angle at a time, the reference angle. The reference angle, the angle that we work with, is never the 90-degree angle. So we'll only want to work with, or we only have as a choice, two angles. We can use angle B in a question, or we can use angle A. We can't use C because it's the 90. So that's the first thing. We always need a reference angle. That's step one for every question that involves right triangles. The second question is we need to label the sides. And to label the sides, we have side opposite, side adjacent, and the hypotenuse. Every triangle needs to have those sides labeled to start the question. But if I look at this first triangle, I can't identify the opposite or adjacent until I know which angle we're using. So step one, and that's why we've labeled it as step one, we need to decide which angle we're using. So for this first one, for argument's sake, I always put these arcs so I can identify and visually see which angle I'm working with. If that's the angle that I want to use in this question, I can now label my sides. The side opposite is the side opposite the reference angle. So if A is my reference angle, opposite the reference angle is side BC, or side lowercase a, that's side opposite. Side adjacent is attached to the reference angle. So now I have two sides. If I take a look at this, there's two sides that make up the reference angle. Well, one of them, actually, this hypotenuse. The hypotenuse is easy to label because we've always labeled it. Opposite the 90 is your hypotenuse. And so the side adjacent is attached to the reference angle, but it's not the hypotenuse. So what's attached to the reference angle but not the hypotenuse? Well, there's side adjacent. So every question is going to have to start with these steps. Identify the reference angle. I like to always label the hypotenuse first, to be honest with you. Opposite the 90 is your hypotenuse. Opposite your reference angle is the opposite, and that leaves adjacent. There's your three sides. The second triangle, let's do the same thing, but let's use angle B as the reference angle this time. We're going to focus on angle B. Can you please label the three sides? Give it a try, and then I'll talk. Pause. So we chose this time reference angle will be B. So opposite the 90 is hypotenuse, always. That one doesn't matter what the reference angle is because hypotenuse is always across from the 90. But now opposite and across from the reference angle is side opposite, and opposite and hypotenuse are labeled, so that leaves adjacent. And the adjacent is attached to the reference angle, but isn't the hypotenuse. There's your hypotenuse, so that has to be adjacent. So those two steps, you might think I'm taking too much time to do that, but if you can't label, you're in big trouble. So now we have the actual trig ratios. The trig ratios are what we use to find angles or sides. We have three trig ratios because there's three combinations that we can work with. The sine trig ratio always compares the opposite side over the hypotenuse. So in a question, if we know the opposite and hypotenuse sides, we're going to use sine. Adjacent isn't part of that, and that's why the word SO is used to abbreviate it. Sine is opposite over hypotenuse. Cosine always compares adjacent over hypotenuse. So if I have the adjacent side and the hypotenuse side, I would want to use cosine. And we abbreviate that CA. So CA, cosine, is adjacent over hypotenuse. Doesn't have the opposite in there, so then that's when we'd use cosine because the opposite's not part of it. And we're left with tangent, which is opposite over adjacent. And so if we're going to use the tangent ratio, we have side opposite, side adjacent. We don't have the hypotenuse. So the way to remember that ratio is TOA. Tan is opposite over adjacent. So this statement, so TOA, helps us to know which trig ratio to use. And we'll see how it gets used and review it. But sine uses opposite over hypotenuse. This is if we don't have the adjacent. Cosine, adjacent over hypotenuse. don't have the opposite. Tangent, opposite over adjacent, we don't have the hypotenuse. So it depends upon what's given as to which trig ratio you have to use. So let's walk through some examples really quickly. We're not solving yet, but these two examples are here to help us figure out, well, which trig ratio would we use? So what's our first step? The reference angle. Well, it tells us for angle A. So we know we're using A as the reference angle. That's always our first step. What's the second step we reviewed? We label the sides. Well, we're going to label it opposite, adjacent, and hypotenuse. So if we're using reference angle A, hypotenuse always opposite the 90. Opposite is always opposite the reference angle, and that leaves the adjacent. Attached to the reference angle, but not the hypotenuse. So that's adjacent. But now, our third step when we solve is to choose the appropriate trig ratio. Well, that means we need to consider sine, so, cosine, ca, or tangent, TOA. So, ca, TOA. When we take a look at this first example, well, what's given to us? Look at what we have. We know the opposite side is 7 centimeters. We know the hypotenuse is 8 centimeters. So there's two pieces of information given to us. We don't know what the adjacent is, so that's not helpful. So in this case, the adjacent is an extra piece of information. If I want to use opposite and hypotenuse, we would use the sine ratio, which is the sine of angle A opposite over hypotenuse. And it has to be sine because the opposite and hypotenuse is what's given, so sine is what falls into place. Try the one on the right, give it a try, same steps, and then we'll talk. Pause the video, and then we'll chat. Well, if we take a look at this one, again, it's telling us to use angle A. So there's our reference angle. We now label the sides. Okay? Opposite the 90 degrees is your hypotenuse. Opposite the reference angle is the opposite, and that leaves us with adjacent. So we've labeled the sides. Opposite, hypotenuse, and adjacent. Opposite the 90 is your hypotenuse, your longest side. Opposite the reference angle, that's why we need to know which angle we're using, because that'll be side opposite. And then that leaves us with the adjacent. Well, in that case, now we need to choose the trig ratio. Well, choose the trig ratio. Adjacent's given to us, that's a good thing. The opposite is given to us, that's a good thing. The hypotenuse, we don't know it. So if we don't know the hypotenuse, it's not helpful. So if we have adjacent and we have opposite, well, what uses the adjacent and the opposite? There it is there, opposite adjacent. So in this case, we need tangent of A, opposite over adjacent. And that's how we choose the trig ratio. Know what your sides are and then look to see which sides are going to be useful. All right, here we go. Last one, give it a try and then we'll chat. Angle A again. So one more. Reference angle A, there it is. There's our 90. Opposite the 90 is the hypotenuse. Here's our reference angle. Opposite the reference angle is side opposite. So that leaves side adjacent. Reference angle, label the sides, and now choose. Which piece here does not help us? Well, we have adjacent, we have opposite, we don't know the hypotenuse, so it doesn't help us. Well, what uses the adjacent and the opposite sides? The sine, opposite hypotenuse. Nope. CAH, adjacent and hypotenuse. Don't have hypotenuse. Nope. TOA, opposite, adjacent. You betcha. So this is tangent of A is opposite over adjacent. That's how we can choose the correct ratio. Well, this background is all the lead up to solving. So, solving unknowns using trig ratios. These steps help us to solve angle sizes. It also helps us to find side lengths. So those are the two things we want to calculate, angle sizes and side lengths. Our first step that we've been talking about, identify the angle you're using, that's your reference angle. Label the sides, we've been practicing that. Choose the correct trig ratio, that's what we've been doing. Now we're going to start creating a proportion using sine of an angle is opposite over hypotenuse. There's the ratio that we have to set up and plug into. Or cosine of A, adjacent over hypotenuse. There's a ratio, the trig ratio that we're going to have to plug into. Or tangent of A is opposite over adjacent. There's the trig ratio we're going to have to plug into. That's what this is talking about. Once we choose the correct trig ratio, we're going to create the proportion because we know the ratios. Here's the goofy one is now we solve. And it has the 4 stars beside it because that's, how do you solve? Well, it depends on what we're trying to solve for. Angle sizes uses a solving method. Side lengths uses a different solving method. 1 to 4, same 4 steps. Number 5 changes. So let's take a look. Let's start on page 7, solving angle sizes. There's step 1, reference angle. Step 2, label the sides. Step 3, figure out which trig ratio. Step 4, write the proportion or the ratio. And step 5 now, to solve angles, we have to inverse the ratio. Well, that's what we have to practice first. What does it mean to inverse a ratio? Well, we have 3 examples here. Example 1 says tangent of A equals 4 over 5. Remember, tangent is comparing opposite over adjacent. So there's a question. The opposite was 4, the adjacent was 5. We plugged it in, and there's what we have. Well, now we need, step 4 has been completed, but now we need to solve. Here's what we do. 2 things. Easiest one is to inverse the ratio. Well, what that means is inverse the ratio means we want to hit the second function and then the trig button. Second function or shift, not sure, every calculator can be a little bit different. But we have 4 divided by 5. So on our calculator, we make sure we're in degree mode. What we're going to hit is we want second function. We need to hit that second function button, and this was a tan question. So we do second function tan. Now we get that funny little -1 there. That's a good thing. We need that for finding an angle. Now we punch in 4 over 5. As a fraction, we use the division. 4 divided by 5 and close the bracket. There's what we want. Inverse tan 4 over 5. And when we hit enter, what do we get? to the nearest whole degree, 38.65, is 39 degrees. So we can go back, and we now know after we did second tan 4/5, remember we got tan with the little 1 and 4/5, and it was 39 degrees because we second tanned our fraction. Now, the other possibility is if you don't have fraction capabilities on your calculator, what you can do is divide your fraction first. 4 divided by 5. Well, that equals 0.8. Now we have a decimal, so we can go second function tan, and now we punch in the 0.8. Hit enter, and there's our same value. That's the same as second tan 4/5. We get the exact same thing, whether we use it as a decimal or whether we use it as the fraction. 39 degrees. Well, now we want to do cosine. What do we notice about cosine? Well, this time, cosine is actually giving us the decimal instead of a fraction. That's okay. We want to go second cos because we're finding an angle. To find an angle, you inverse. We're going to go second cosine, and then we're going to punch in the 832. And that will give us our angle. But because it's an angle we're calculating, we have to start with second function cosine, get our little -1, 0.832, close our bracket, and we get an angle of 33.6952, which is just 34 degrees. Because we had our proportion, it's already been made into a decimal, we second coast it. Try the sine C. Sine C 8/9. See what you get, and then we'll talk. Well, what do we want? Second function sine, because we're finding an angle, and it was 8 divided by 9. So I could punch it in as a fraction, 8 divided by 9, and we get 62.7 or 63 degrees. What was the other choice? Well, we could start by dividing our fraction, and now we have our decimal. We do second sine, but we should always punch in multiple decimal points. I like 4 decimal points. Putting in 1 decimal point, in this case, wouldn't work. We only used 1 decimal place previously because there was only 1 decimal place. If our division has multiple decimal places, go to 3 or 4 decimal places. And when I second function sine that, we can see it's not exactly the same because the decimal 888 should really be more 8s, but we are so close, it's still 63 degrees. Angle C is 63 degrees because we second signed the 8/9. So that's the last step in solving angles. Here we go, page 7, number 3. We want to calculate angle B. So if we're calculating angle B, identify the angle you want to work with. Well, if we want angle B, that's the angle we're going to work with. There's our reference angle. Second step, label your sides. Opposite the 90 is the hypotenuse. Opposite the reference angle is the opposite, and that leaves the adjacent. Third step is to choose your trig ratio. Choosing our trig ratio. Which side isn't going to help us here? The adjacent isn't going to help us. So we need to use the opposite and the hypotenuse. To use the opposite and hypotenuse, this is sine. And we're using angle B. So we want the sine of angle B, which we know is opposite over hypotenuse. So if I plug into that, sine of B, opposite, we see as 4, and hypotenuse, we see as 14. There's our proportion we've created. We chose the correct ratio, and then we created our proportion. How do we solve? We second function sine 4 over 14. And that will give us angle B. Second function sine in this case to get the angle. 4 over 14, and we're second sining. So we go to our calculator, second function sine 4 divided by 14. Close your bracket, and what do we get? 16.6 or 17-degree angle. What's the other possibility we talk about? We could first divide the fraction, 4 divided by 14, to get a decimal. Now we second sign, and we punch in the decimal. 4 decimal places. 0, decimal, 2, 8, 5, 7. And that's still going to be 16.6 or a 17-degree angle. Same thing, either way. 17-degree angle. There's your trig solving an angle size. Page 8, take a look at number 4. It's a bit of a word problem. Word problem means we have to have a what? A right angle triangle. So it starts off by saying we have a 19.8 meter tall tree. So 19.8 meter tall tree. There we go. Look at how impressive that is. And it's casting a shadow along the ground. Well, we know the tree casts a 22-meter shadow, and we know the tree is 19.8 meters tall. A tree and the ground meet at 90 degrees. Top of the tree to the bottom of the shadow, there's our right triangle. Have to have a right triangle in this. Now the question wants to know the angle of the sun's rays with the ground. So where do the sun's rays meet the ground? Here's the sun up here. It's shining down. There's its ray. Where does it meet the ground? Right there. There's what we're trying to find. Where the sun's ray meets the ground. There's the angle we want. Takes a little bit of time. Now you can try to solve it. Stop the video, give it a try, and see what you come up with. Here we go. Reference angle, check. Label your sides. Hypotenuse. Opposites. Leaves the adjacents. Choose it. Well, we have adjacent, we have opposite. Hypotenuse doesn't help us. I'm going to call this angle A for now. What now is opposite and adjacent? Opposite and adjacent is tangent. So the tangent of angle A is opposite 19.8 over adjacent 22. Hypotenuse isn't in here. So there you go. Reference angle. Label the sides. Choose the piece that's not helpful, which then helps you choose your trig ratio. We can set up our proportion. And now we want to inverse second tan 19.8 over 22. Tan inverse 19.8 over 22. That will be angle A. So 19.8, 22. What do we have here? Second tan in this case 19.8 divided by 22. What do we get for an angle? 41.98 or 42-degree angle. But one more time, some calculators, if your calculator doesn't let you punch everything in, what can we do? 19.8 divided by 22. Look at that. It's a decimal that ends, so we'd only need one decimal place. Second 10 now, 0.9. There's our 42 degrees. So angle A is 42 degrees. The sun meets the ground at 42 degrees. So there's solving angle sizes. Back to page 7. It's a bit of a long video, but it's not too complicated, I hope, because you've seen it before. Now we want to solve side lengths. Well, how do we solve for side lengths? Again, identify the angles you're using. Label the sides, not new. Choose your trig ratio. Little different, but still, is it going to be SOH, TOA? Create your proportion. But now the solving for a side, we cross multiply. We don't need to second function here. Cross multiply. Well, it'll look something like this. Because this time, if we're finding a side, we might have, this is a little add-on that I'm giving you right now, we might know we have a 25-degree angle, and we might know that the opposite side is 5, but we don't know the adjacent. Because tan, remember, is opposite over adjacent. So this time, what changes when we're solving side lengths, we'll know an angle, but we don't know a side. So the question says to cross multiply. Well, what we do to cross multiply is we can always put our trig value over 1. Now we have two ratios. We've used this a lot this year, and now we cross multiply. Multiply what you know. This will be 1 times 5, and we then divide by the extra piece. But be careful. Our extra piece isn't 25. It's tan 25. So we need to make sure we push that value. 1 times 5 divided by tan 25 will equal x. So that's what we'll plug into our calculator. We had 1 times 5. I like to hit equal there just to get it out of the way. And then we're dividing. We don't hit second function. It just says tan 25. Our little -1 isn't there because we're not doing second function. We're not inversing. We just want to divide by tan 25. 1 times 5 divided by tan 25 gives us 10.7. So in this case, because it's the adjacent, x, what was it again? I've forgotten already, is 10, and lengths usually go to 1 decimal place. 10.7 is the adjacent length. So that's what it means when you have to cross multiply. So another situation. Cosine, remember, is adjacent over hypotenuse. So let's say we know that the cosine, we wanted a 50-degree angle is what we were using. And we, in this case, didn't know the adjacent again, but we knew the hypotenuse was 30. So we could plug in, and we would have cosine 50 is an unknown adjacent over a hypotenuse of 30. How do we cross multiply? Take our cos 50 and put it over 1. What can we cross multiply in this case? Be careful to find the things that you have. Here, my cross multiplying is going to be cosine 50 times 30, and then I divide by the extra piece, divided by 1. And that will equal the adjacent side for this case. Cosine 50 times 30. Let's go to the calculator. Again, No second function. We're not finding an angle. Cosine of 50, close your bracket, and we want to multiply that by the length of 30. Cosine 50 times 30, it equals that. I divide by 1, which really doesn't do anything. So in this case, we get a length of 19.28, which rounds to 19.3. So x equals 19.3. Solving side lengths, this cross multiplication process is key. So let's take a look. Page 7, solving side lengths. Let's find side B. Wow, this is interesting. I forgot to add lengths in here. Let's put those in. This is question 2. We have 26.7, and we have a 32-degree angle. And we want to find side lowercase b. Well, let's remember that lowercase b is always opposite angle b. So there's what we're trying to find. Now, we still have to go through the same steps. However, little twist. Identify the angle you're using. Well, we never use angle B. So which angle should we use, C or A? Well, if we're trying to find B, we should definitely use the angle that we know. I want to use what I know to solve for what I don't know. So that's going to be our reference angle. Label the sides. Label the sides the same way. Opposite the 90 is hypotenuse. Opposite the reference angle is opposite. And that also leaves adjacent. Now again, we need to choose the trig ratio. Well, which side isn't useful to us? Well, in this case, I like to look at what is useful. Adjacent's given to us, that's a good thing. Opposite's not given to us, but hypotenuse isn't given to us. But which one's more important? The hypotenuse is important because that's the side we're trying to find. So the hypotenuse is definitely what we want to use. The opposite doesn't help us in this case. So what do we have? We have adjacent and hypotenuse. Adjacent and hypotenuse tells us we need to use cosine. So we did the same steps as before with a little twist. Reference angle, because we know it. Label our sides. We want the hypotenuse, so we're going to use it. We have the adjacent, so we're going to use it. Opposite doesn't do anything for us. So we're using the cosine. Now we create our proportion. But what's important is now we know what the angle is, so we need to make sure we put it in. Cosine of 32 is adjacent. Remember, cosine is adjacent over hypotenuse. So cosine is adjacent 26.7 over hypotenuse, which isn't known. Step by step, follow the points. And how do we solve? Cross multiply. Cosine 32 goes over 1. What can we cross multiply in this case? I'm just going to write this a little bit so I can read it better. We have cosine 32 is 26.7 over the unknown, and we set that over 1. There's what we can cross multiply. 1 times 26.7, and we're going to divide by cosine 32. Again, we don't have to second function because we're not finding an angle. So 26.7 and cosine 32. We have 1 times 26.7 equals, and we wanted, whoops, wrong button, sorry about that. 1 times 26.7. That equals. And then from there, we want to divide by the cosine 32. Don't second function. We're just dividing by what's there, the cosine 32. And that's 31.484 or 31.5 for a length. 31.5, and that's the length of our hypotenuse. 31.5. And so far in this case, 26.7 was given to us. We calculated 31.5, which is at least on the right track because we calculated the hypotenuse, and it is the longer side. So, page 8, last example. I know this is a long lesson, but lots to get, but it's review, and it's similar. Here we go. Two trees are 100 meters apart. So here we go with my pretty drawing again. Two trees. Oh, look at this nice tree there. Oh, look at that. I could draw birds in there if I wanted, but I'm not going to. And here, there we go. There's our two trees. We know they're 100 meters apart. And they're 100 meters apart, but halfway in between. So that means we have 50 meters and we have 50 meters. You can look up 65 degrees. Well, here's our 65 degrees because that's looking up. And here it's 55 degrees, not as many degrees because it's a smaller tree. We don't have to angle as high. We want to know the difference in heights. Well, here's the difference in the heights. This here is what we're trying to find. What we can do is find the height of tree 1, find the height of tree 2, and subtract them. So there's two calculations. So number 1, first, here we go with number 1. Which angle are we going to use? 65 degrees. Why are we using 65? Because we have it. So let's label our sides now. Sorry, I don't want to use that pen. Use red. 65. Label. Across or opposite the reference is the opposite. Opposite the hypotenuse, or opposite the 90 is hypotenuse. That leaves adjacent. We want the opposite. That's what we're trying to find. We have the adjacent. Hypotenuse doesn't help us. Adjacent and opposite. We have tan of 65. And remember, tan is opposite over adjacent. Tan of 65 is opposite, which is unknown, over adjacent, which is 50. Set it over 1, and we cross, multiply, and divide by the 1. So tan 65 times 50. Here we go. Tan 65. Oh, make sure you close that bracket. Tan 65, close the bracket, times 50. And I divide by 1, which really doesn't do anything. 107.2 is the height of the tree. 107.2 meters tall. Well, now I have to do the same thing for tree number 2. So tree number 2, it's a whole new triangle. Reference angle, use the one that's given. Label the sides. Opposite our 90 is hypotenuse. Opposite the reference angle is opposite. That's what we're trying to find, and then we're left with the adjacent. So, which side is of no use? We want the opposite. We have the adjacent. Hypotenuse does nothing, which again is going to be tan. 55, opposite over adjacent, x over 50. Set it over 1 and cross, multiply to find a side length. Tan 55 times 50, tan 55, close our bracket, times 50, divide by 1, gives us 71.4 for the height of the tree. So in this case, 71.4, that's what it was, I forgot it already. 71.4, yes, meters tall is tree 2. So what's the difference in their heights? 107.2, and I want to subtract the 71.4. and we end up with a difference in heights of 35.8 meter difference. Difference in heights. So, a long video. I hope you managed to follow along, but we did a lot in that. It's review very much the same steps over and over. Practice them now. Not a ton of assignments, but you have page 9 and page 10. It is so important to understand and make sure you get the differences to how to solve for an angle versus how to solve for a side. Practice, please, ladies and gentlemen, and then have a great day.